Okay, so this is the simulation that I've built. I have a power simulator, which is the monitored battery. I have the current simulator, and I have the button inputs as well as LEDs. So what I've done so far is I've been able to display the voltage measured as well as the current measured and get inputs from the button. So this button works as a select button, which is on D0, PD0. This one works as I think this is the down button, which is on PD2. PD2 is the interrupt. See it here, into int 0. And the other button, which is like a out button, is on int 1, which is PD3. Now, so if you click the down button, you can see the LCD response, right? And this is like the bottom, and this is the end. And you can see if the user wants to set up the LCD, the battery management unit, he can go to this page and click the select button. Or if he wants to just continue, he can just go back to the start. Or if he is on this page and he wants to go back, he can click the up button. So yeah, and then back to the setup page, he can click D0, which is the button for like say select, to go into the setup menu. And these are the different settings you can have, well, that I've done so far. So you can see him can set the time, then you can click the down, you can set the date, then the battery voltage, then the maximum temperature, max DOD, these are the thresholds. Or he can just exit the setup, or he can go back up if he missed the one he was looking for. I haven't done any selecting to like say, set the actual time. I just make the menu. Or if you want to exit him, go there and click the select button, and it returns back to this page. He can choose which he wants to display. Okay, so yeah, that's it for what I've done so far. So I'm going to explain the program now. Well, not necessarily the syntax, but the logics behind what I did. So I'm not going to explain how to set up the buttons and check the registers, etc. I'm just going to see what is what and then explain the logic behind it. So into the code, I used this from what Dr. Fortner gave, which is the lcd.h and lcd.c, which initializes the LCD. So yeah, this is basically what I got from Dr. Fortner. I didn't think I modified this. So now buttons.c. I just use this to initialize the buttons. So PD0. Now PD0, which is the select button, is on D0. But notice there is no interrupt on D0. Well, there is no int 0 or int 1. There's a different type of interrupt called the pin change interrupt. So I configure the button to work on this interrupt. And for PD1 for the second button, I just configured it to work on int 0, falling edge, and D3 configured to work on int 1. No, D3 is int 1, and this one is the reset button. So that's it for the buttons at C. Just configure the buttons based on the data sheet. You can check the comments, set pull-ups, etc. So the next one is the reading of the ADC. Okay, I just separated them so that I won't have all the code in main, so there will be less code in main, so yeah, it will be easier to go through. Okay, so in terms of the ADC reading, I created a function in this C file, right? So what this function does is when you call this function, it takes in a value, an integer, and the integer corresponds to the ADC pin which you want to read. So the ADC pins are PC, are the PC pins, are the port C, right? So if the user want to read a ADC value on PC0, he will put in 0 in the function, and then from that input use a switch to configure the ADC reading. So case 0, if the user input 0, you configure the ADMUX to read PC0. Case 1, you configure the ADMUX to read PC1, and so on. Then do PC4 and 5 and 6 because we aren't using those to read ADC. Those are for different stuff. What next? So yeah, after it configures, after it configures which ADC it wants to read from, it basically just, this is the same configuring. So based on the data sheet, and then it starts the conversion. Then when the conversion is finished, it returns ADC, which is the number from 0 to 1024. So it returns this value. Oh my lord, Proteus has been malfunctioning. So yeah, it returns the value. So the while loop waits until the conversion is complete. We reset the flag, then it returns the ADC value. I also made a different function. So like if you don't want the ADC value from 0 to 1023, I made a different function which returns the actual value that the pin reads. So if the pin reads 3.5 volts, this function float ADC voltage returns 3.5 volts. And this function also factor in stuff like if you divide the voltage in order for the ADC pin to be able to read it. So like while reading the battery voltage, we would have used the voltage divider, right, to step down the voltage. And this configuration gives a 11 to 1 ratio. So it basically divides this by 11. So when you read the voltage, you will have to multiply it back out by 11 to get the actual voltage. So this function takes in the voltage divider ratio. So in terms of reading the battery voltage, you will input the pin that you want to read, same, the pin number you're reading from, and this is the voltage divider ratio. If you didn't do any voltage divider ratio or anything, you put 1, right? And then what it does is it calls the previous function, which is this ADC, to get the actual ADC, well, not the actual, to get the value from 0 to 1023, and it stores it in this variable. So after it stores it in this variable, it returns this variable multiplied by 0.0048 times the voltage divider ratio. So now the 0.0048 is the 5 volts divided by 1023, which means for every decimal, that is, for every value that is returned from this function, it is equal to 5 divided by 5 divided by 1023 volts. So if I get 500 from this reading the ADC, then you multiply it by this to get the actual voltage. And then this is just the voltage divider ratio to get, in case you did divide it down while you're reading. Okay. Yeah, that is it for the ADC reading. This was just a different something that I had, but I realized that it was unnecessary. Now, time for the interesting parts. Okay. How do I start? You initialize the LCD in the main function, which this function comes from the LCD.c, basically setting up the LCD for 4-bit mode, and it also configures the pins, the data pins for the LCD, and the data pins are these pins. So it's set these pins, the 4 to D7, as output. So the 4 to D7, where it sets them as output, because remember you want to output the data to the LCD. Yeah, sets it up for 4-bit mode. Yeah. This part is configuring the timer 1, because I wanted to use the timer 1 to keep track of the real-time date and time. So it sets it up CTC mode. Output compare register is actually 32,000 some, but I just put the one there to speed it up in the simulation. So yeah, so you can refer to the data sheet to see how to set up the timer 1 as in CTC mode, and this one enables interrupt when the timer reaches the value that you load in this register. So this enables timer 1 compare interrupt. So every 1 second it will interrupt, and you can increment the time. Buttons, this basically calling the function that I wrote in this, which is initializing the buttons, which is the input, and int 0, int 1, and the pin change interrupt. this, I just put this here to just clear the LCD. So like make it blank when when it just start up. I don't think it's necessary, but I was having an issue where when I reset the LCD, when I press the reset button, the LCD will just not respond anymore. And I was trying to solve it using this, but still didn't solve. And then you set the global interrupt. Oh, okay. So skip ahead, skip ahead, skip ahead, skip ahead to this, which is this is a function for an LCD page, and it takes in a lot of variables. So this basically selects which page that the LCD displays. So like when I was running it, you will see like different stuff when I press the buttons. So yeah, that is being controlled by this function. So how it works is it takes in page number, which is the pages that are displayed on the LCD. So if I run it, and it won't take forever. Wow. Ooh, oh my lord. Yeah, that has happened sometime. So fatal simulation error is like when it can verify the product key, like the internet slow. So what if you remember from the start when I was clicking the button, the pages were being changed. That is being controlled by this function. So what I did was I create a case, well, a switch function which selects the page that you want to display based on this variable that is being input in the function. So case 0 will be the displaying the first page, which was this, just some text. Case 1, it displays the current and the state of charge, right? So how it gets this is from the how it gets the current and the state of charge is from above. Where is it? Where is it? Where is it? Where is it? Hold on. Wait, my bad, my bad, my bad. It's actually right here. So what this does, it creates a variable to store the current, a character, because the LCD, you print a character variable, and it creates a variable to store the state of charge. And this is just a helping variable. So this is also a different variable, which is to read the current. Now, in terms of reading the current, you use the ADC function. Remember, this function returns the actual value, right? And you input the pin that you're reading from and the voltage divider ratio. In terms of the current reading, there is no voltage divider ratio because we just taking the input from the sensor, the ACS 712 module. So this gets the actual voltage, right? And then this part has to do with the sensor. So like the temperature sensor, when you get the actual voltage, you would multiply it by something to get the temperature in degrees Celsius. this, well, I think this gives the temperature, the current in amps. What I did here, this converts the float to it converts the float to a string, right? And then you can see how this function works. This is the amount of digits you want. This is the amount of decimals. So having two decimals mean you have only one digit. So it can only read current from 0 to 9 amps. Well, the current won't exceed that because remember our rating is 5 amps. Next thing, if this is just formatting. That's all I can tell you, because like when I was printing the currents on the LCD, remember the current can be, oh, this is tricky to explain without showing, but just know this part is formatting. Oh yeah, I remember when you convert the current value to a string, remember the current can be negative and positive, right? So when it was negative, it put a negative sign, but if it is positive, it does not put a negative sign. So what happened is that if the current was negative and it increases to positive, the negative sign will still show on the LCD display, because remember it doesn't have a positive sign. It just doesn't put anything, it just leaves it as the actual value. So the negative sign will still show if the current move from negative to positive. So what this does is it says if the first digit in the character, remember if it was the first digit is like the first letter in the string. So if this is not equal to, and this is the ASCII for the negative sign, which is basically the dash, this. So if the current is, if the first character in the string for the current is not equal to this, then where the negative sign would have been printed on the LCD, you want to overwrite that from the negative and put positive to show positive, right? This print start is another formatting for the LCD. So that's less important. Yeah, and it just, after it done dual conversion, it have the string. You just print it, and the first line you want to indicate what you're printing, and on the second line I print the state of charge. I didn't calculate the state of charge as yet, but so I just put a random value, and then you print the value of the current. Yeah, print the value of the current under current, and you put the A for amps, and then you break out of this case, which is the case for the page number 1. If the number you input in the function was 2 now, which means the user wants to see page 2, it's basically the same thing. You can just follow the same thing that I just explained in terms of getting the voltage. As you see page 2, you want to display the voltage and temperature. So you just read the voltage, you read the temperature, right? And then you convert it to a string, then you print it, you do some formatting, to make sure it print properly. Yeah. So this part is reading the temperature, converted it to string, reading the voltage, converted to string. I don't know why I have this delay. It can come out, it can come out. Now, case 3 now. Case 3 is where you display the date and time. Wow. So this me can tell you this is basically lab 4. So if you remember, we had a variable hour 1, hour 2, minute 1, minute 2, because for the time you have you have 00, which is hour 1, hour 2, 00 again for the minutes. Yeah, that's the time. So like 12:45, etc. For the date, I just use the months, the day, and the year, but in the format of day, month, year. And for the year, I think I only did the last 2 digits, like 23 for 2023, etc. Because it was too, it couldn't fit. It couldn't fit. Why, in terms of getting the AM and PM, yeah, I just have trust and believe. Alright, so you can skip this if you want to get into detail, but I'm going to try to explain it. Because that's the purpose of this. So before we can go through this, which is displaying the temperature, the date and the time, we have to see how you actually read the date and the time. Keep track of the date and the time, and yeah, you have to see how I keep track of the date and the time. So remember, we had set up the timer one to interrupt every 1 second. Right? And for every interrupt, you have a vector. So this is the vector that tracks the time. Bam, bam, bam. So these variables were created above. So the second variable, which represents the second. So every time the interrupt, remember the interrupt is called every second. So every time the interrupt is called, you want to increment the second variable. So it goes from 0 to 60. Right? When it reaches 60 now, so if this second is 60, you want it to increment the minute. Right? Minute 1, as I said before, you have hour 2, hour 1. This is single digits, right? Then minute 2, minute 1. This is what I'm displaying. So this can be 12, 40, 12:20, 3. Yeah. So in this case, minute 1 will be this digit, minute 2 will be this digit, and so on. So if when this reaches 60, which means 60 seconds has passed, you want to increment this, right? And you want to set this back to 0, so it can count another 60 seconds to increment this again. So now this keeps incrementing until it reaches 9, as it counts up to 29. And then when it's ready to go to 30, so if this minute 1 is equal to 10, because I wait until it reaches 10. So when the interrupt is called and second reach 60, say minute was 9 before and minute increments to 10, you know that minute is not supposed to increment to 10, but minute 2, which is this, supposed to increment, so it can go to 30. So if minute 1 is equal to 10, you increment minute 2. Minute 2 is this. And then you set minute 1 to 0. Minute 1 is this. So this goes to 3 and this goes to 0. Oh, I hope this recording here. I'll be so upset if it's not. Okay, yeah, so you get this. And then if minute 2, this, this can go up to 60. Well, it doesn't show 60, but in the code it comes to 60. So when minute 2 reach 6, then an hour has passed and the hour needs to be incremented, etc., etc., etc. Now, in terms of the which let me I'll explain. Oh yeah. In terms of knowing whether it's AM or PM, right? This is what we do. I use a variable AM PM to determine whether it's AM or PM. So remember, when the user sets up the clock, he will input this. So he will input AM or PM. So in the code, when I declare the variable, I set AM or PM to -1 by default. So you can see if AM PM variable is equal to 1 with +1, then it's morning. If it's equal to -1, then it's evening. So by default, the clock will be evening unless the user changes it. So working from that, right? So what we want to do now is to check whether it's morning or evening. And how we do that, how we check whether it's morning or evening is by, morning and evening is every 12 hours, happens every 12 o'clock. So every 12 o'clock, it changes from morning to evening, or from not morning to evening, AM to PM, or from PM to AM. So every 12 o'clock, it changes. So what this does is it looks for when the time is 12, when the time is 12:00, 12 o'clock, 12 o'clock on the dot, right? And if this time is 12 o'clock, it inverts the variable in AM or PM. So if AM or PM was, so if it was AM in the morning, right, AM, so if it was in the morning, initially, then AM underscore PM, the variable, will hold 1 because +1 represents morning. So if it reaches 12 o'clock now, it will change from being morning to evening. So what I did is I multiplied AM or PM, which was the 1, by -1. So this line basically inverts it. So, if you multiply 1 by -1, it becomes equal to -1. So if it was morning, right, and the condition of 12 o'clock came where it changes from AM now to PM, it multiplies the 1 by -1. I remember -1 represents PM, which is the evening. Now, if it was evening, then AM or PM will be equal to -1, and you multiply it by -1, and this gives +1. So you can see it just alternates between positive or negative whenever it hits 12 o'clock. So that's how I kept track of the AM or PM. Now, this part, what does this part do? Oh yeah, this just basically resets this part. So if our 1 is equal to 1, no, if our 2 is equal to 1 and our 1 is equal to 3, that's where the condition is saying if it is equal to this, then we're working with 12 o'clock. So if it's equal to this, you want to reset it back now. So it starts from 1 o'clock in the morning. So you set hour 1 is the first digit of the hour, to 1, and hour 2, you set it to 0. So that's what this line does. Yeah, wow, this is a lot to explain. Now, the next thing is the counting of the date and time. Interesting stuff. Okay, so to count the day and time, what I did was, the days will increment every time it changes from PM to AM. Hope you understand that. So if it was PM, so 11 o'clock in the night, and it changes to AM, a day has passed. So the day will increment. So we're working from that. So what this does, this checks if a day has passed. So, another thing in this variable checks if 12 hours has passed. So, I'm not sure if this is necessary, but I just put it. So every time it changes from, like, say, AM to PM, or every time it hits 12 o'clock, every time it hits 12 o'clock, it sets this variable to 1. So if this variable is equal to 1, which means 12 hours has passed, and the AM or PM, which is if AM or PM is equal to 1, which is morning, so 12 hours has passed and it is morning. So remember, this is in the if it is equal to 12 o'clock function. So this is this function. If it is equal to 12 o'clock, then our pass is assigned 1. So if it is equal to 12 o'clock, right, and AM or PM is equal to 1, which represents morning, it a day has passed, which therefore means you increment the variable day. The variable day, this checks the amount of days, increment the days. So the 1st, 2nd, up to the 30th of March, every month days is in the month. So increment the day. Now, how we know how much day is in which month? Because the days in the month different for each month, right? So how do we know this? So we can see if it is the 28th of February and a day has passed, you increment it to March. How do you know that? We know that by this declare the array with the amount of days in each month in that array. So for the 12 month, I place the amount of days in each month. Now, how do we increment the month now? So let's say we are on day 28th. No, so did the increment and we are on 29, right? Day 29. And the month initially was February, and it's not a leap year. So if the day increments to 29, what this function does is it says if the day, right, that we are currently on is greater than the days in the month that we are currently in. So I forgot to mention this. I had a variable that also checks the month that we are in, keeps track of the month that we are in. So we can, if we are in January, it is 1, February 2, 3, 4. So if the day that we are currently on is greater than the day in the month that we are in, so remember the number of days in each month is stored in the array, and January is stored in the 0th array. So month will have 1, which represents January, but in the actual array, the first space in the array is represented by 0, so that's why I'll subtract 1. So back to the scenario where we are in February. So it is February 28th and the day increment because 12 hours passed. So now it goes to this. If the day in the month that we are currently in, so if the day is greater than the days in the month that we are currently in, so for February, this will be the month. February is the second month. So this will be 2 minus 1. So whatever the values in the array for February, because February holds the first, it is at the second month, but in the array it is the first position. Position 1, not the first position, position 1. Right. So the month minus 1. So if the days is greater than the days in the month that we are currently in, we increment the month. So the month now will increment from January to February. So the month will, in February, the month was 2. Now you increment it, 2 plus 1, the month is now 3. And you set back the day to 1, because if the month change, the day reset. So you start from the 1st of February. March. Hope I'm not saying the wrong stuff. Now, this is changing the year. If the month was incremented from, say, December is the 12th month, right? And say the month was incremented because the days exceeded the days in the month, then this increase the year. So if the month is greater than 12, because you only have 12 months in a year, then the month is reset back to 1 and you increment the year. This is an integer. So that's how date and time is tracked. Why this video is extremely long, but I hope it's extremely clear. So now if the user wants to display date and time, and so for case 3 in the switch, we call that we take in the page number that you want to display, and the date and time is the 3rd page. Alright, so it will have these variables. These are character variables to store the individual digits. So back when we were keeping track of the date and the time, we were storing them in integers, but we want them in characters, so we just make some character variables. So ITOA, this function converts a string, an integer to a string. And yeah, so it takes in the integer that you want to convert, the character variable that you want to store it in, and this 10 represents decimal. You can do it in hexadecimal or whatever you want to, but we work in decimal. This basically converts the hours. This is the month. No, this is the time. This is the date conversion, and this is the printing. So you print at the first row, date and time, and then we print out the dates. I remember how we incremented its individual digits. So hour 1, hour 2, and then minute. I don't know if it's in the correct order. I think it's minute 2 come first and minute 1. So I think it's 2 come first. So yeah. So this is like 12:40 or 12:20. So yeah, it converts the individual digits and store them in individual characters. So that this is this conversion for the date and the time. Then it prints hour 1. Remember hour 1. No, it prints hour 2. Hour 2 is this one. And then it will print hour 1, and then it prints the colon, then minute 2, then minute 1, and then it jumps a space over to align with date. No, it prints AM or PM. So yeah, this back to the AM PM variable. If PM is equal to -1, remember -1 represents PM. This is a different variable. But if PM AM is equal to -1, then you need PM. If it is equal to +1, then you need AM, which is morning. And you print this after the time. So you can have 12 PM or AM. Then you want to print the date. You just print the date is more simple. Wait, yeah, the date should be more simple. You print LCD print day. Alright, if day is equal to 1, then this is another formatting for the LCD. So you don't need to worry about that. This is a slash between the date. You print the month that we are in. This part is another formatting, because when it goes from, say it was December and it goes from 12, which is 2 characters, now to January, which is 1 character, because January is the first month. Then since it moves from 2 character to 1 character, the second character, which was there for December, would still be on the display. So it will print the character for the January, which is 1, but it will leave the character for December. December has 1, 2. It would leave, I think it left the 2, and it didn't erase it. So this erases the 2. And then it prints this for the slash, then it prints the year. How did I get it to print just the last 2 digits? Can't remember. Then it comes out of this for the setup. The setup page here is just a printing. Case 5. This is so page 5 is now, from page 5 onwards is now the settings page. So page 5 is the first page in the settings. Bam. So if the user press select while the user is the LCD is displaying this page will appear, page 5. And then page 6 is basically page 5. It's the same thing. if the user press the down button, but it change the arrow for the selection. So you can see the arrow was on time first, then it goes on date. And these are controlled by the buttons. The page numbers are controlled by the buttons. Soon explain that. Then page 7 is a new set of menus starting from the arrow pointing on the first one. Then when the button is pressed again, the arrow goes down for this. And then when the arrow pressed again, the arrow goes down for different selections. And yeah, that's it. Now all that's left to explain is the button press. So remember that the buttons were set up on D0, D2, D3. D0 was configured to be a pinch interrupt. So it's an interrupt same like the int1 into int 0. So ignore this if statement for now. Remember, I had to do this because the pinch interrupt is a little different from the other interrupts. Because so in terms of for the other interrupts, you can decide whether you want it to configure to trigger on the falling, rising, or level edge. For this one, you can't do that. So this is how I figure out how to get it working. Alright, starting from the down button. So every time the down button is pressed, the interrupt is triggered, and the page number, the variable page number increments. That's the first thing you want to know. So therefore, when it exits that interrupt, the function that is doing the printing, right? The page number will change, and it will, if it was on page number 0 first, and it increments to 1 will now be in here in this function, and in the definition of the function, right, 1 will be here, so it will change from this case to this case. So this case is page 0, and then it changed case 1, which is page 1. So it works like that from from all the pages except in the settings page. So if it reach the settings page and you press this button again, it does not go into the settings, right? So the first 5 pages are the normal pages outside of the settings. So the normal pages, which is this page, displaying this text, the current state of charge, then the temperature and the voltage, then the date and time, and then the setup. Remember, the key start at 0. So case 4 is actually the 5th page. So back in the interrupt. So as long as the page number is less than 5, right? Every time this button is pressed, it executes. It executes this increments the page number. Oh yeah, it executes this as long as the page number is less than 5. So basically it cycles between the pages. So it goes from page 0 to page 1 to page 5, and you can see if it reaches page 5, right? If it reaches page 5, so this is basically saying if the page number is pressed when it is on page 5, remember, this corresponds to the case. So it's, don't get mixed up, this corresponds to the number stored in this is the case number. So it goes from 0 to 4. So case 4 is actually the 5th page. So if it is on page 5, no, if the number is greater than 4, so let's say this is where the confusion comes in. Oh, all right, I see. So, all right, page number, if it was on page number, if the value stored in page number was 4, 4 corresponds to page 5, right, which is the setup page. So if the value was 4 and it comes into the interrupt, it will increase it to page 5 same way. But page 5 is page 5, page number equal to 5 is corresponds to the 6th page on the LCD. All this is because the cases start from 0. So if the page number is 4, if the page number is 5, it increments it. But remember, page 6 is going into the settings page and you don't want that happen. So what you do is you check. So if page number, if it is on the 5th page, then you set it back to 0, which will cycle back to the beginning. So if it is on the last page, the settings, the page that asks you to select to input the settings, and you press this button again, it goes back to the start. And the up button just decrements the page number. So if it was on page 1 and you press the up button, it decrements. This is basically the same thing. If it is on page 1, right, and you press the button to decrement the page. So remember, page 1 is the top page, first page. There is no -1 page. So if it's on page 1 and you press the button to go up, it jumps back down to the bottom, which is the page that's asking if you want to input the settings. And then if you press again, it goes up, goes up. Now, how it goes into the setting is if when it is on page 5, which is page 5 is case 4. This, when it is on page 5 and you press the select button. The select button is the button that is on the page change interrupt. So when this button is pressed, remember the if statement is how I get the something to work. So if page number is equal to, the value stored in page number is equal to 4, which corresponds to page 5, then you increment page number. So you can see this, only this button can allow it to go in the settings. And then when you're in the settings now, settings is page 6 and above, or case 5 and above. So when you're in the settings, only then the when you're in the settings, the up and down button works just the same. So you just carry it up or carry it down, the selection. Where was I? Yes. So this if corresponds to the settings. So remember, the settings page is from the settings page is from page 6 onwards, and page 6 is case 5. So if page number is greater than page 6 and it is less than page 11, because what you don't want it to do is when it reaches the bottom, you don't want it to increment again. So it only increments if it is uh, it only increments. So if it is on page 6 to to um to page 10. So if it reach on this page is page 12. Case 11 corresponds to page 12. If it reach on page 12, then it cannot increment. It won't increment because there's no other page. I haven't created the other pages yet. And the decrement works just the same. Yeah. No, wait. I was highlighting the wrong thing. This is the decrement. So yeah, while it's in the page number that corresponds to the settings, it increases. Decreases, which corresponds to. This is the up. So it goes up when I press the button. Up in the settings. This part goes down in the settings. How you exit the settings now? Remember the settings page. The exit settings page is case 11 or page 12. So if the number stored in page number is equal to 11, so if the number stored in page number which is equal to 11 is equal to the exit page, then, and if the number is equal to 11 and the button was pressed and the interrupt is triggered, then it sets the page back to the first page, which is page 1. Or no, case 1 is page 2. Yeah, page 2, which is the state of charge and the current. And yeah, that's all I have. That's all I have. And it was very long to explain. I'm not even halfway. So yeah, you can see it cycles through. This is the variable of page number increasing as you press the button. Page 2, page 3, page 4, page 5, and this only cycles through. This reverses, decrements the page number, and if it is on the setup page and the select button which is on the pin change interrupt is pressed, it goes into the settings, and this continues to increment the number in the variable page number and decrements it. There. And then to exit, you go on the exit page, and then if if it is on the exit page and you press the button, it jumps back to page 1, which displays the current and the state of charge. I hope you understand, because it was very long. How do you start?